Live.
Yep.
Hello. And welcome to my life. It doesn't say live now. Okay. Okay. Family. Live again. Hi.
Connor said, can you go over elements?
Yeah. Of course I can.
Right. Hold on, let me just get you in position. Is that okay?
Yeah. Yes. Okay. 1, 2, 3. Action. Do you do electrolysis? Yeah, I did electrolysis before, actually. What we learned off electrolysis was actually that positive was anode, negative is cathode. So like positive will move towards cathode, which is negative, and why do I keep looking at that when I can look at this? Negative will move towards anode, which is positive. I think yeah. So the positive will actually move towards negative, and negative will move towards positive. And to word that to get high grades would be anode, cathode. So anode is positive, cathode is negative. I feel like a genius. I didn't even know that before. What is an element? So, if you want to know what an element is, go to page 97 and read the top. Right. So an element is a substance made up of atoms. Mom, can you please close the door? So an element is a substance made up of atoms that have the same number of protons in their nucleus. So the nucleus is basically it's the middle of the atom, so where there's loads of circles. Yeah, just loads of atomic. Yeah, it's just an atomic radius. So it's like it contains protons, neutrons in the middle. So that's like negatives, positives. Can you do properties of structures? Properties of. I'll see if I've got that. Properties of. got structures here. No, not that one. Got metallic bonding. New metallic structure. I know, I'll put it away probably on Friday because I've got no exams on Friday. I actually don't have that. I don't have. Ionic and covalent bonding stuff. I have actually done that today. So yeah, ionic and covalent. I'll check it for you in there. Ionic and covalent. So you wanted to know metallic structure. Properties. Right, so I've got properties. What do you want metallic structures? Well, these metallic structures, so I'll see something. Oh, it's metallic bonding. Well, if you want me to do metallic bonding, I can do that. Yeah, metallic bonding. So that's this on this page, which is page 120 if you've got the combined science. Which page is that now? Metallic bonding and alloys is on page 4447. Okay. Right, so I've actually got like a revision book that I can help myself and yourself off. So first of all, it says draw the structure of a metal to show metallic bonding. So metals are giant structures of atoms. So basically it's the positive, so it's like a plus sign with a circle over it. So I actually did that, so I'll show you an example of the so metallic bonding is right here. Can you see that? Shall we moving that way? Yeah. So metallic bonding is actually the plus sign, where there's loads of minuses around it. So that is the plus is positive metal ions, and the one with minuses is delocalized electrons that are free to move through the whole structure. So yeah. Oh, by the way, that's not actually my handwriting. That's just because I was rushing through my revision in class today, because I just got out of an hour and 45-minute exam. I'd got out at I finished school at 25 to 3 and I got out at 25 to 4. So I finished an hour after school actually finished. Excuse the hair. I was in the hot tub before, so it's gone big a bit. Because I treat myself to the hot tub when I'm not revising. But metallic bonding, the plus is positive metal ions, and then the minuses around it that look like minuses. I don't know what they are. It's just delocalized electrons that are free to move through the whole structure. So electrons plus ions are held together by, pardon me, I don't know why I keep doing that. Held together by electrolysis forces. So I'm gonna sit on my knees because my knees are really hurting. I mean, yeah, my legs are really. No, I'm gonna sit on So if you like coloured pens like me, I'm full of them, just full of coloured pens. I love pens that are colours. So if you love pens that are colours, you will easily revise, because having something that's there that's in colour, it'll help you to remember things. So say you did a plus, red with a circle, minus is black, you would tell that pluses, you'll always remember that pluses are red and minuses are black. So you'll always remember positive. The plus is positive metal ions. Negative is delocalized electrons that are free to move through the whole structure. So if you want to write that down, write it down and keep reading over it, because if you don't keep reading over it, you're probably going to forget. So metals, okay, where's my book? Metals are giant structure. Can't get my words out. Metals are giant structures of atoms. So what I mean by that is what I've just shown you, giant structures of atoms. So just atoms really. So it's just the pluses with the circles, that's metal atoms. So yeah, so metals are giant structures of atoms. So giant circles with pluses in the middle. Look, you have some. I'm going to ask my teacher if I can sit right in front of the class tomorrow. I'm going to sit in front of the class. I've lost my glasses. I've lost my glasses.
That's because you're too busy messing around about and then being staying in school and revising.
Needed food, Mum. The electrons in the outer shell of the metal atoms are free to move around, which I've told you delocalized. Yeah, it's delocalized. Literally. So I've said that. So that's the minus ones. So delocalized, meaning that the particles can move freely wherever they want, just like us, but it's on the outer shell. So there are strong forces of electrostatic attraction between the positive metal ions and the negative electrons. So negative electrons are literally the delocalized electrons. That's negative. Am I lying to you? I might be lying to you. So there are strong forces. I'm going to repeat that again. There are strong forces of electrostatic action between the positive metal ions, which is the circles with the pluses in them, and the shared negative electrons. Yeah, electrons. Which is delocalized, which particles are able to move freely. The reason why I keep repeating the same thing is because it helps you to remember it. These forces of attraction are known as metallic bonds. So, literally, what your question was is metallic bonds, which I've just gone over. They hold the atoms together in a regular pattern. So it's just the repeated pattern. So it's like 4, 3, 4, 3. and then the delocalized atoms are just placed anywhere around the actual positive metal atoms. So positive hold together from the outer shell, and the outer shell, which is delocalized, are able to move freely. But yeah, metallic bonds help hold the atoms together in their regular pattern. So bonding in metals affects their properties. Metallic bonds are very strong. Mother, I need my phone charging. I've got school tomorrow, you have not. Let me go back on the live a minute, because I just need to see if anybody ever messages me, so then I'm not being ignorant. Oh, why have I just liked it? You see, been on YouTube for so long and still do not know how to get the what do you call it? Messages up. Well, you'll now know metals are giant structures. Okay. Right. Well, I'm going to go into some slides that I actually have, which will also help. 2007. Go on YouTube. Go on that, and I'm able. Nope, I'm not on that one. I'm on this one.
Hi guys, and today we're going to be doing chemistry.
Nope, we're not on that one actually. I'm lying.
So guys, you get the joy.
I'm sorry that I'm taking for long. It's just that I don't know how to get messages up. Like, imagine I did. That'd be flipping amazing. Usually it just comes up, so I never really have to worry about that. Well, that's annoying. Let's go back on it. Right. Well, doesn't seem to be working, but we'll go on to slides. And if I can't see your messages and you're messaging, don't think I'm ignoring you. I actually can't see what you're putting because I don't know how to work YouTube. Because I know I've been on a family YouTube channel for quite a long time, but I still do not know how to work YouTube specifically. I don't know how you do this. Right, I'm gonna go onto the slides first because that will then help you. So if I go into Gmails and I go onto chemistry paper 1. Chemistry, no, that's physics, that's physics, that's physics, that's biology. I need chemistry. Where's chemistry at? Chemistry paper 1. Right, open in slides. So I have got chemistry open. Wow. Wowzers. Right, let me find a Bob's this. Page 20. Nope. I'm on page 48. Page 32. Nope. Page 41. Close. 42, 42, 42, 43, 43, 43. No. 44. Yeah. Right. So draw the structure of a metal shown in the metallic bonding. Wow. Are you serious? So will it not go to the side? No. Okay, so why am I showing my phone? So this is actually the slide. So this is the structure of a metal to show metallic bonding. So the positive, as you can see, is the metal atoms, and the other one are delocalized electrons. Did it? Oh my god! Smart. If you're saying anything, I'm so sorry. I just really don't know how to work this at the moment. If it did. No, honestly. I don't even know how you do it. Right, well, we're just going to get to it. And if you're saying anything, sorry that I can't respond to you because it's just not letting me. No, it's still not letting me. Right, so metallic, no. Metals are giant structures of metal ions, which is positive. In a regular pattern surrounded by a sea of delocalized, which are able to move freely, electrons. The electrons from the outer shell of the metal atoms are free to move around, and there are stronger electrostatic forces between these electrons and the metal ions. These forces are called metallic bonds. Ow, 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 ow. So I'm going to read that out again. And I'm going to read it slower so that it can help you. And whatever you remember with what I've said, write it down. So then that will help you then remember what was said, and what you remember is what your brain is functioning and what your brain is not functioning, obviously. So metals are giant structures of metal ions, which is positive, in a regular pattern surrounded by a sea of delocalized electrons, which delocalized means that electrons are free to move through the whole of the structure that is actually made. So through the whole, positives everywhere. Sorry for the hand moves, but it's actually helping me. Perhaps not me. So the electrons from the outer shells are the metal atoms, which are free to move around, and yeah, I've already said that. And there are strong electrostatic forces between the electrons and the metal ions. The forces are called metallic bonds, which metallic bonds is what we are actually on right now. This is still annoying me. Why is it not going on the chat? Like, I want to go on the chat. Please. So write as much as you remember down. Why is it not doing it? Right, I'm gonna go on to how to go onto the chat. How to go onto a chat on YouTube. On YouTube. So this is so embarrassing, but I really need to get onto the chat. So you should know the structure of a metal to show metallic bonding. So if you wasn't here when I said it, positive is metal ions. The minus ones that are able to move freely are delocalized. Oh my god. Don't know what you're saying. Don't know what you're saying. Right, I'm just gonna go with the flow. Then live. Right, I'm pressing live. And oh wait. Nope, still nothing. No, what are you doing? No, don't want that. We don't want that. We don't want it. And if we don't want it, we don't have it. What's that? No, I don't want to. No. Wait, what? Help and feedback. Nope. Don't want that. We don't want that. No, we don't. Captions. I don't want that either. I don't even know. Right. Really? I can't do this. Right, well, it was working before. Don't know why it's not working now. So if you're saying anything, sorry that just message me on Instagram if you actually need anything for me to go over. I'm doing revision on Monday night for, I think is it the geographer? Is it? Sure, it's geographer. So I'll be doing revision next week, yeah, for geography and maths on the Monday. I'll be doing that. And on Tuesday I'll be doing science physics paper 1, and on Wednesday I'll be doing English, modern text and poetry. So stay here for that. But yeah, if you need to message me on Instagram about what you're trying to ask me, my Instagram is s_Imogen X. No spaces, no capitals. s_Imogen X, all lowercase. So just message me and I'll accept if you need me to go over anything, which I will happily accept. Oh yeah, so we'll go back onto the slides. Oh wait, don't need that one, I need this one. And we are going to explain why metals have a high melting and boiling point, and explain why metals are good conductors of heat and electricity, and explain why metals can be bent and formed into shapes. So explain why metals have a high melting and boiling point. So this is because metallic bonds are very strong, and so a lot of energy is needed to break them. So I'm going to say that slower. Metallic bonds are very strong, and so a lot of energy is needed to break them. So yeah, they're strong. So they can't slide to like. Why did I just do it like that? What's going on? So they can't like move, like slide, like that's enough, like a that's like geography, that like plates without sliding. Yeah, about that. Also, the explain why metals are good conductors of heat and electricity. The delocalized electrons can move through the whole structure, which I've said a million times, and the electrons can carry electrical current and or thermal energy. So it can be and or thermal energy. So also, I'm going to read that out slower for you to get into your brains. The delocalized electrons can move through the whole structure. The electrons can carry electrical current and or thermal energy. That's electricity. See, sleepy brain. Explain why metals can be bent and formed into different shapes. The atoms are found in layers which can slide over each other, which I've said. So literally atoms. So if it's like a spoon, the reason why it can actually move is because the layers move, and they can just move all different directions because it can bend. Also alloys. So what is meant by alloys? An alloy is a mixture of two or more metals, or a metal and other elements. So I would just stick with an alloy is a mixture of two or more metals. How are alloys made? The pure metal is melted, then mixed with either the other metal or the other element. Use the diagram to explain why alloys are stronger than pure metals. This is to make an alloy, another substance. To make an alloy, another substance is added, which has had different size atoms. The different size atoms disturb the layers of the metal atoms and make the layers jumbled. This means the atoms cannot slide over each other as easily. So the alloy is stronger. I really need water. Sure, I have a water somewhere. Over my bed. Nope, it's not there. I left it in the car now. Or did I? Not a clue. What? I'm just gonna quickly go over. So I've gone over metallic bonding. So obviously it's pretty late now. So it's 10 minutes till 11:30. So I'll be back Monday night. I'll try and do it earlier. If I get home earlier, I've got a really bad headache. If I get home earlier, then I will do this earlier. But I hope this was useful. I did metallic bonding. I was going to do elements, weren't I? Well, I'll quickly go through elements because I know that somebody wanted elements, which I actually didn't do. So, in case you need elements, I'll quickly go over some elements now. So, what is an element? An element is a substance made of only one type of atom. Where could we find a list of all these elements? Well, the only answer is the periodic table, because that is literally where all the elements are. That is where the only elements are, because the elements are the periodic table. Do the diagram shown on the element on? Wait, what? The diagram shown on the element. So I'm going to go all the way over back to the front. So if you see these, is it this? This. Why would you do that? Right, so I'm pointing at this one. So we're going to start off with the end one. So this is no. Wait, yeah. This is no, a compound. This is two elements. This one is elements. This one is a mixture. Element. So I'll do this again. So as you can see, if you can see my phone where the light is, this will help. Why do I keep putting it over there? Right, so let me show you this. If you can see this. Try and draw it if you can. If you can pause it and draw it. Pause it and draw it. And get the questions down, which I will happily shine a light on. So these. So this is a element. Two elements, a compound. It says no, a compound, but that makes no sense. That one is a mixture. Element. So to help, that's an element, and that's an element. So to also help you, elements are basically the ones on their own. So like circles on their own, triangles on their own, more circles on their own. What's the definition? So I'll go through what else is in it. Nope, I'm not on that one, mate. Elements. Isotopes. Right, isotopes. So what is the definition of isotopes? So isotopes is an atom of the same element with the same number of protons but different number of neutrons. Explain why these diagrams show isotopes of carbon. They all have 6 protons. However, they each have a different number of neutrons. 6, 7 and 8, which is pages. So I'm gonna leave it there because I'm knackered. Never been more knackered in my life. Mum just messaged me and said that it's very late. Yes, I know. Good. My exams are going good. Great. So yeah, I'm gonna leave it there, and I hope you do well on you tomorrow, chemistry paper 1. I also hope for the best, seeing as I have just done a revision session, which has also helped me, because I did not know electrolysis. I did not know anything about elements. The other thing I learned, what was the other thing? About distillation, was it? Metallic bonding. Yeah, I didn't know anything about that, but now I do. So thanks to whoever popped up about metallic bonding. And I hope to join you if you've got geography. Be on Monday's stream. I'll try and do a Sunday one. Try and be on Monday, and if I do Sunday, geography. And if I do 2 days, one will be geography, one will be maths. So Sunday will most likely be geography, and Monday will be maths. So I'll be here for Monday because that'll definitely be a maths one. And if you're doing geography, I will be here on the Sunday. So good luck tomorrow on your GCSEs, and have a good sleep.